Hey everybody, welcome to Fishtory, and thank you so much for your support. All of you who are members get to see this early in the week. It's always an audio-based episode about fish, history, new fish species, new plants, all sorts of exciting aquarium news, and you guys make it happen, as well as the rest of the content on this channel. I really do depend on members and your support and your views for this, as well as those of you who watch on the Aquatic Morning Show and those of you who come check out my page when you see this elsewhere. I just have to announce a big, exciting new breakthrough, and that is that we officially will have a podcast. So all of the Fishtory episodes will be uploaded soon for a podcast and will be available on all podcast platforms. So that's big news. I wanted to say that. I couldn't do it without you guys, and I really appreciate it. So episode number 160. New evidence may explain when humans, or rather Homo erectus, first mastered the use of fire and even rudimentary aquaculture and possibly agriculture. So, the close analysis of the remains of a carp-like fish found in Gesher Benot Yakovik, an archaeological site in Israel, shows that the fish that were found there were cooked roughly 780,000 years ago. Almost a million years ago, folks. Cooking is defined as the ability to process food and control the temperature at which it is heated until it is of a satisfactory level of cooked until, or heated, I suppose, until it is edible. So it includes a wide range of methods, but until now, the earliest evidence of cooking appears to date to around 170,000 years ago in Africa itself. So the fact that this is outside of Africa and almost certainly done by humans, or at least one of our common ancestors of Neanderthals, humans, Denisovans, and other human-like Homo sapien relatives, is crazy. This puts the date 600,000 years earlier and also highlights the importance of fish and food and how they moved out of Africa. So around this same period, we're talking way before the Ice Age. This is 3 ice ages ago. And it was a warm period when the Sahara and the Middle East were actually a bit warmer. And so there were these lakes all over what is now the Sahara, the Sinai Peninsula, as well as the Middle East and what we now call the Levant, Israel and Lebanon, Jordan, all the way up through Turkey and over into Iran and Afghanistan. So the incredible part of this is that they found this site over a century ago, and now due to new testing technology, they've been able to double and triple check the age of this site. So a Dr. Zohar and a Dr. Provost, they studied this site, and they said that it demonstrates the huge importance of fish in the life of prehistoric humans, their diet, their economic stability, and further their expansion. So by studying the remains of these fish that were found cooked and disarticulated, basically, they were able to reconstruct for the first time the fish population of this ancient lake bed, which was known as Lake Hulla, and show that this lake held a now extinct species of unique fish. This is a good-sized lake, and these fish included giant barbs, which are in the aquarium hobby, and also a carp-like fish that could reach up to 2 meters or 6 feet in length. So the large quantity of fish remains found at the site proves that there was frequent consumption for thousands of years by early human ancestors. So they developed special cooking techniques, and these new findings demonstrate not only the importance of those freshwater fish habitats, but also the importance of that technology to control fire in order to cook. Things like heating stones and then moving them away from the main fire, burying them next to fish, and sometimes forgetting to dig them up, for instance, and they find a carbonized, cooked remnant of a semi-fossilized fish next to these heat-cracked stones that are buried, things like this. So the study researchers specifically were able to date things focusing on the pharyngeal or throat-like teeth that grind up hard food such as shells that belong to this big member of the carp family. And these teeth were found in large quantities all over different archaeological strata at this site, but also in other sites in the region. And the structure of the crystals that form the enamel of those pharyngeal teeth through exposure to heat, we can tell when they were heated in these almost like tree ring patterns and how hot they were heated. So next to this lake, there were several campsites that were apparently established and used for thousands of years. So we can tell that they were not burned by a forest fire. They were not burned just randomly by fire. But these fish and these stones were heated, and then the fish was cooked to probably between 300 and 400 degrees, which means it didn't incinerate. It actually roasted it. And one, this is the first time we can say that happened. And two, it's also showing that out in the desert, even then it would have been semi-arid, that they had this lake, and they're probably next to the lake. They are gathering wood from somewhere nearby, and they're able to carry fire with them. And we know this from other sites, that humans at least were able to carry torches and set fires where they wanted to, and in odd places where, you know, a lightning strike wouldn't get, like the back of a cave or something. And we can see that they've started them over and over and over and things like that through soot and other deposits. But it's new to prove that they were eating raw food that had been then transformed by cooking. That is new information. And it is a quantum leap in human history, because what it shows is that we were able to access a massive amount of calories for our human brain to grow. And that's what it was doing during that time. So arguably between 1 million and 500,000 years ago is when the modern human formed. Someone that you would, if they had been schooled and so forth, you would sit on the bus and maybe they look a little hairier, a little bit different, a little out there from another time or something, but they're not like knuckle dragging chimpanzee people. They could pass for humans, and their brains would think like a human. And we know this about like Neanderthals and things now too. So the flesh that they find in these sites is rich in omega-3 fatty acids, zinc, iodine, as well as things that would stop scurvy, because these fish are eating smaller fish. They're big enough and high enough on the trophic level that they have those nutrients in their fat. And so they realized that the people came to this lake from far away. There's no other sources of water nearby and no river that they can find that would have led into it. And they believe that the freshwater locations that are scattered around, kind of like oasis, even during this warm and wetter time in Earth, later became an arid desert. And it's probably the passageway that these early humans left Africa out of. And it's probably those sources of fresh water and fats and calories that allowed us to develop our brain and allowed us to move out. And there's been a lot of debate at what did it. Was it us standing up to look at game we were hunting in tall grass? Or was it early swimming mammals? I mean, there's been all sorts of archaeological explanations over the year. But now we can say, at least we can add a piece to the puzzle saying that prehistoric humans were leaving Africa 770,000 years ago, and that 2 million years ago we had around 2 million years ago we had evidence of humans fishing, or human-like ancestors fishing, and we found fish deposits at sites where they were encamped. But this is a real revolution that the Archelaean age, or Archulean age, depending on how you say it, and I like to say Archelaean, it shows us that there's an important change that happened here, that man, woman, that we figured out how to master the environment between fire, shelter, and then cooking protein. it allowed us to leap forward. It allowed us to preserve things. And between also fermenting and drying, and smoking, we were probably able to carry this food with us, and also render things like, bladders from larger game animals. We were able to use those in baskets and pottery later on to carry water as well. So we could make the trip through these desert regions and through these regions. But this region was dotted with lakes at this time. Afterwards, it dried out. It got wet again at one point, but there's not an evidence of a big mass migration at this time. And what it may have been is that Africa was actually getting too dry, and the northern pocket of African human ancestors had to leave. They had to get out of there because it was becoming a desert, just like it is now. So they were able to do this through several layers of dating, both through the enamel of the fish's tooth, but also through isotopes in other fragments of bone and material in the site. And they were also able to reconstruct the hydrological conditions, or rather what the lake and stream and like what all that was like, and how it looked every season, because there was sediment that would fall and pollen samples and things that would tell them what was growing in the area and all that. And they can show that these people were living here year-round. So this also shows some of the first sites of year-round inhabitation, because they show that there are fish being harvested for like 2,000 or 3,000 years at this site year-round. So these are major breakthroughs. This is in the Journal of Science, in the Journal of Nature, and it's also in a couple different forums for peer review in Israel and European journal sources right now. But it's huge news. Me as an archaeologist, formally, or I guess I still technically have the training, but in any case, it really blows my mind, because when I was in school, we didn't even know if humans were mixed with Neanderthals at all. And now we know that everyone except the African humans that are from Africa ancestrally, everyone outside Africa had Neanderthal mixed in, and parts of the people around the world have Denisovan, and maybe even Florentii man, and maybe the little could be also the Hobbit person, the Florentia man as they call him, or Florin man. Some named off of I think it's named something off the island of Formosa, south of Thailand. Thailand used to be called Formosa. Anyways, that's where that naming comes from, because in the Pacific Islands they find these small people. But regardless of all that, this is just huge news for the archaeological community, and it happens to cross over with my other favorite hobby other than history and archaeology, which is fish. And that it was crucially important, and that the bones of all the humans found in the area had high sources of omega-3s, 6s, and omega fatty acids. And they wondered, where were they getting them from? They're not near the coast. Where are they getting them from? They're not eating shellfish, just eating oysters off the beach or whatever. And this answers a lot of questions just from one site, or at least proves that this kind of lake hopping was a way that they may have left Africa. It may be how we got where we are now, whoever you are, wherever you are, unless you're in Africa watching this, then you may not have left. Anyways, I hope you guys enjoyed that one. I think I might do a full episode on this because it's just so incredible, but I will check back in with you guys soon. I hope you have a wonderful day, and thanks for tuning in, guys. I'll see you tomorrow. Bye. What's going on, everybody? This is the biggest syndicated channel there is about fish and history. Well, at least exclusively about those things, and new science about fish. So thanks for watching. It makes me feel good that there's other nerds as big as me. So episode number 161, mystery solved, mapping eel migration routes across the Atlantic. So this is kind of an interesting follow-up, because there's actually a book called Eels that came out recently, and that had a lot of the same information. But recently we've been able to do more than speculate, and we've actually been able to fasten little geo-tracker tags to eels and follow where they go. So since the time of the Greeks, it's been a mystery where the European eel goes. And all the way through medieval times and throughout the 17, 18, 19, even the 20th century, humans were like, where do these go? They leave the Mediterranean. We never see baby eels. We only see like mid-size and big adult eels. That's it. And these eels are usually around 2.6 feet long, 80 centimeters, give or take. And they enter the Mediterranean, and that's all they knew. So they figure they're coming from somewhere outside the Mediterranean. Well, it turns out that over the years, they've tracked them down, and they found that they go to the Azores. Well, they rest in the Azores, islands off of kind of the African coast. Used to be Portuguese, Spanish, French, all sorts of different people have landed there and tried to colonize it. But for around 1,000 years, give or take, there's been people there for sure, maybe much longer. And eels are one of their big delicacies. And the eels that get there are rather large, bigger than European eels, to the point where they would be like 3 feet or 100 centimeters long. And Europeans would report when they'd go there that they would see big eels. So now we knew, okay, they're going to the Azores. And when researchers put this all together, they then figured out that they're going from the Azores to the Sargasso Sea. And where is the Sargasso or Sargasso Sea? Well, it's out in the middle of the ocean, out by the Bahamas and the Caribbean, kind of. It's out in the middle of the Atlantic. And what it is just a big body of water out there that's rather warm, and that the jet stream that goes back towards Africa, that goes up the North American coast kind of, and then cuts across the ocean over through Iceland, Ireland, just south of there, down the UK, and then back to the mouth of the Caribbean, that it's there. And that's where this water pathway goes right now. And so it turns out that finally, after looking all over the world, they finally found some larval, like very small, half a centimeter, a few millimeters long, baby eels. And the only place they've ever found them is in this Sargasso Sea, or this kind of Caribbean area sea. So they figured, okay, they've got to be having babies over there, but what's going on? Are they all going there at the same time? And so a professor named Dr. Wright and her team tagged a bunch of these big eels in the Azores. And that was a couple years ago. That was in 2018. Then just now, in October 2022, they have published research saying that they tracked 21 of those eels on a southwesterly trajectory towards the Sargasso Sea. And most of the tags popped off before the migration was done because they're eels. But 5 of the eels made it into the Sargasso Sea, which is where they've found larval eels. The only place in the world they've found these larval eels. So the tags and the data reveal why these eels are so elusive. And it's because it's a massive voyage. During the daytime, they dive as deep as 5,000 feet, almost a mile underwater, 1,500 meters plus. And at night, they swim, quote unquote, close to the surface at 200 meters or 700-ish feet deep. And it's still too deep to be spotted by anyone on a ship or boat or anything like that. And their digestive systems dissolve, and they remake themselves into reproductive organs, the tissue in their digestive system. And they're in no rush. They actually store energy while they're eating and growing to this huge size in the Azores, and then they take their time. So they swim about 7.4 miles or 11 kilometers a day at most, and it means that they take 18 to 22 months to cross the sea from Europe to the Sargasso Sea. And in other words, these eels left Europe this fall, and they're not going to be spawning until at least spring of 2024, the ones that they just tagged, that they're talking about in this paper. Once the eels spawn, they die, so they're kind of like salmon in that way. And this natural rhythm of the cycle of life continues for the eels, and so then the babies make their way back, floating on the currents and eating little bits of whatever eels eat. They're still trying to figure that out. So since the 1980s, their numbers, though, have declined by 95%, the European eel. And some of the threats to the species are probably ocean-going phases of their life, where they're really vulnerable to certain things that we don't even understand yet. Or maybe something that used to eat, say, tuna, is no longer getting enough tuna, and now it's eating these eels. But it's pretty clear that with them swimming that deep, they may not be equipped to make these journeys in a quick and stealthy manner, other than being deep like that and a dark eel. And so it's really fascinating for us to get all these questions that now we have to answer about how are they getting there? How can we help them exist? And if these baby eels take, up to 2 years or a year and a half to mature and come back, then what can we do to help them make it all the way back? It's a really crazy story. If you want to read more about it, definitely check out the book Eels. Lawrence Kent lent me that. And I also want to give a shout out about the episode yesterday on early man and fish, early women and men, early humans and fish, and give a shout out to one of our viewers. I don't want to call her out in case she doesn't want that, but thank you so much. And I didn't find that article, surprisingly. I'm sure it would have eventually, because I'm a big nerd, but she sent it to me and I was like, how did I miss this? This is so cool. Anyways, back to the eels for one more moment. So now they're trying to preserve the eels, and because you can't really make a case to preserve something if you have no idea where you're preserving them or what you're doing to preserve them. And so far they haven't been able to breed them even artificially in captivity because of this feeding phase out in the open ocean, following the currents and going so deep underwater. Now we need to understand, what are the babies doing? They're probably in the top water is the guess, because there's more food and light and plankton and stuff. But maybe they're down deep too. Maybe they follow the frickin' ocean floor. We have no idea. But it's a mystery that goes all the way back to Socrates and Aristotle, and as well as Carthaginian and Egyptian scholars even, that were perplexed why they never saw baby eels. And now we know. Now we've seen a few baby eels and we've followed their parents, and we know that they have a big eel orgy out in the ocean. So I hope I said that fast enough that I'm not going to get flagged. But if I do, you won't see this video. If I don't, have an awesome week, you guys. I'll see you tomorrow. Bye. Alright guys, it's Alexander Williamson, and we're on episode 162 of Fishtory. Today is kind of hump day, so let's do a nice and easy one. Moms that eat their babies. So, mouth-brooding fish eat their babies. New science finds this out. You're probably thinking, duh, especially if you've owned any cichlids before. Yeah, the new study that just came out says that mom gets stressed and oftentimes swallows her eggs or even her live baby fish. If you have fish that move their babies even, you'll know this already. Any fish keeper knows this. However, I guess they needed to do a study to officially note it and to know things about it. But the interesting part about it is that it's actually a really good strategy to keep your fish handy and in your mouth, your babies, because they found that mothers that ate during their whole life and that never gave birth and were chosen as the queen or the alpha female, kind of one of them, not that there's one, but that they're not one of the dominant females and they didn't ever reproduce, that they had 25% higher quality of DNA and no liver damage other than normal aging, whereas which was the control for the males too, whereas the other females that had been mouth brooding had all sorts of chromosomal and DNA damage from starving themselves while they keep the babies, especially if they'd done it multiple times. And in fact, for each time they did it, their liver enzymes would crash around 12%, and their DNA seemed to be about damaged 24% more than the non-brooding mothers for every batch they carry. Now, this means that the ones who are holding the babies may not be the females who are going to be mated with over and over again by the males. The males may, know this because that DNA is getting degraded. So it brings up some new questions. But what's interesting is it also shows that this is a strategy evolutionarily to have a quick snack ready. And they know now that when cortisol is increased in the water, or when it's released within the bloodstream of these fish, several different mouth-brooding fish, from bettas to cichlids, and they mostly were looking at cichlids here, but there's anecdotal and other citations about past research that notes that, other mouth brooders also eat their babies. And the thing that they noticed was that when they ate the babies, it prevented that DNA damage. It prevented that liver damage, and it prevented a lot of the other, starving to death type effects that happen, because those mothers are so committed they will starve to death. And the fathers also, just like with plecos too, they will guard an area and not go get food if food's out of reach. If it comes to them, that's great, and in the aquarium we can provide that for them usually. But if they can't get food, or if the mother doesn't eat enough food in between batches, she will be willing to usually let herself die. And they're trying to understand why some of them will let themselves starve to death to take care of their babies, and others are like, nah, I'm just gonna eat them, I'm stressed, enough of this, I'll spawn next year, or I'll spawn in 6 weeks, or whatever. So it's really an interesting idea once you dig into it a little bit. Even though on the surface of it, it sounded like a really dumb study, it does bring up some interesting questions, and also some interesting things about just why they evolved to do this, and why very, very similar structured fish and their bodies and, their habitat and everything, why they don't mouth brood, or what their body goes through in the aging process versus the ones that do this, versus live bearers, for instance. What implications could it have for humans who we have miscarriages, for instance, and so that's a way where we don't necessarily get the nutrients back that we have saved up to have a kid. And I know that's a really grim thing to talk about, but when you think about it from an evolutionary standpoint, when you're all starving to death, if you have a bunch of incredibly nutrient and calorie rich little eggs stored in your mouth, that's really interesting. Now, one last interesting thing about this that I wanted to point out was that the females, it was proportional to their cortisol levels. So if they were super stressed, they would eat up to all of their babies. If they were only partially stressed, they seemed to only eat a chunk of their babies. So some of them ate as few as 25 babies out of over 100 eggs counted in the initial laying. So that's also kind of interesting too, that they may sacrifice some for the others. And maybe there's a taste, maybe she can tell that they're rotting or something's wrong with this batch. And they're also looking into that, because we know that in other cichlids, they can tell the weak babies sometimes, and the males will oftentimes eat those. So it's kind of interesting, fish cannibalism, as we're talking about it. That will probably get flagged. Everything's getting flagged. So I did a video on mushrooms a couple years ago. We went on a nature walk, and nothing at all nefarious about it. And it got taken down, and I have a strike against the channel right now. So I have to be a good boy for 90 days or another one, and then I'm on probation, and then the channel goes goodbye forever. So hopefully nothing else gets flagged all of a sudden. They must have changed something in the algorithm. But again, supporting the channel, supporting me on these Fishtory episodes, which may become fully audio at some point now that we have a podcast that's going to be up in the coming weeks. And all of that really matters so much to me, and it helps me continue this if you guys enjoy these episodes. All right, guys, I will talk to you tomorrow, and I hope you have a wonderful day. Unless you're a member, only $1.99, remember that. And you can listen to all these episodes in one go while you're changing your water or whatever, or driving. And if you like doing that, if you like binging them, then there you go. There's nothing stopping you from listening to all the days at once. However, everyone there on Fishtory, I hope you guys are hanging in there. You're probably like, Alex, shut up by now. But thanks for sticking around and putting up with me, or joining me, depending on which boat you may be in. And back to you, Jess, and whoever's there, Fishymon, Fishy John, John the Fisherman, whoever's there, any of y'all, back to y'all. Bye. All right, everybody, you made it to the end of the week. You made it to number 4 in this installment of Fishtory. You made it. So how you guys doing today? I hope you're doing well. Hope your tanks are doing well. I'm about ready to go to Ohio with my wife and visit family, her family. My father-in-law's having his 75th birthday. We're going to surprise him. Good thing no one in my family pays any attention to what I do on YouTube. They know I exist. They know I do something with fish, and that's about enough nerdiness for them, let alone my wife's parents. But welcome to episode number 163. And today we're going to be talking about tiny coral reef fish and how they parent and how they choose when their embryos hatch. So this is a study out of the University of Texas at Austin, and man, they do a lot of good research out of there about marine biology for being landlocked. So scientists report a documented case of coral reef fish directly regulating when their offsprings hatch. So male neon gobies hatch their embryos, the male does this, by removing eggs from the nest that they have, and they remove them from the nest with their mouth, and then they transport them to a newly hatched opening within a sponge where they leave the babies to grow up. So it's kind of like the little Finding Nemo fish, the clownfish, where they live in sea anemones. Well, these ones live in sponges, and they allow these porous sponges, which have all these holes in them, to house the larval fish. So once the eggs hatch, they put the little egg larva into these tubes of this porous sponge, and then they eat algae and biofilm and all sorts of other stuff that the sponge is taking in to eat with its little flagella. They kind of clean those off, and they probably offer some protection against, modestly small but larger sized predators of the coral that may be like eating them, parasites and so forth. Maybe snails or crabs or something like that, like little baby stage ones. So it's probably, they don't know for sure, but it's probably a mutually beneficial relationship because it's one that's evolved and seems to be working out. So then the fathers, they put them in the little sponge, and then eventually the sponge, it gets too tight for the baby, and the babies come jolting out of there. And this provides evidence that just like humans, fish parents can make adaptive decisions based on local conditions that influence the survival and the resilience and the success of their offspring. So in a lab, Dr. Majori and their colleagues found that neon goby embryos developed without parents, and they would hatch less synchronistically. That is such a hard word to say. Synchronistically. And that they would be underdeveloped and up to 50% less incubated. So the eggs would hatch sooner by double the speed than those that are cared for by parents. So somehow the goby parents appear to know the best time to open up the embryos, to rip off the rubbery shell around these larvae and say, you're on your own now. And when the parents are present in a full ecosystem, they know when to rip off the shell. And the study said that they hatch their offspring at sunrise, generally on the 7th day of embryonic development. And that the embryos that received parental care waited for the parents to choose the right time. So they hatch the embryos on day 7 consistently, the ones that just do it on their own. And then they let the parents choose in the other tank. And the goby embryos are ready and waiting. They can actually see prey. And that was another study we talked about a few episodes back where we said that embryonic fish can see prey and predators. And so they actually are looking at food and danger and things, even though they're in an egg, which seems odd, right? Well, it turns out maybe they've gone through this evolutionary trick before. Maybe they have done this same thing and had their parents control when they hatch. So the offspring hatched by their parents are larger and more developed, which makes sense. They've had more time in the egg. And the ones that hatch on their own are smaller. They have a weaker immune system. They seem to be more prone to disease. And also they're far less good at catching any little predators, any microorganisms living on those sponges. And they can't navigate or orient themselves in the ocean. They just have to go with the tide like plankton or like a larval state fish. Sorry if you see me like spitting out here. It's very cold and you can see my breath, so I've got the lights on really bright, and I probably look crazy to all my neighbors at 3 a.m. talking about fish and talking into my hand. But anyways, what I wanted to say is that the study found that the fish, not only did they survive better, they went on to have more successful spawning partners, so they were better health. They were able to move themselves around. They were able to eat and find stuff. And it kind of begs the question, like the episode we talked about yesterday, well, why don't the parents just eat the eggs that are no good? Like, why do they pick a time? And it's not that they pick the same time for all the eggs, but they pick a select few that seem to be really hardy and doing well, and they'll make all those hatch at once. That seems to be the key. And so maybe that's why, is they're not counting their babies before they're hatched. They're going to give them all a chance for 7 days. And if conditions are good, they'll pop them on the 7th day if there's no one around and there's lots of food and there's no predators. But if there's lots of predators and not much food, maybe they'll wait for them to get a little bit bigger. And I don't know if these gobies eat their own yolk sacs or absorb them. I'm sure they absorb them to some degree, but I don't know how long those yolk sacs last. So are they just being kept in this little bubble as protection, or is it also nutrients that whole time? That I would like to know. So maybe some of you know about this neon goby. That seems like a really generic name, and there is a Latin name, but I didn't write it down. But maybe you already know by the description what this is if you're a reefer. So I'd love to know what your opinions are on this or any other episode. And if you made it to the end and you binged it all the way through, you sons of a guns, you great people, let's have a secret word this week. Elephants. So if you say something about elephants in the comments, I'll know that you watched it all the way through in one chunk. Or you watched this episode and decided to stop by and do it in one chunk. And you know what? I'm feeling foxy this week. I might release this episode to the public because that main topic, the first one this week, whew, boy, was it a stunner, talking about humans and how fish were probably our main protein source almost 1 million years ago, and probably helped us leave Africa and go take over the world. Wild stuff. You never know where fish are going to turn up. You never know when my nerdy connections are going to connect to one another. But that's part of the fun of this podcast and why I enjoy this and the channel so much, and you for sharing your time with me. Thank you so much, and I'll talk to you next time on Fishtory. Bye, guys, and back to you, Jess.